Okay, so hello and welcome everyone to today's quiz session. So we have ended with our live session classes, and today is just a quiz session where I will be discussing basically some of the previous year questions and all. Basically, uh, it's going to be a quiz type. So I have a few questions for you people. I would be discussing the answers as well. So that's all. So I am Srijan Sen, and I'm going to take today's quiz session. So let us begin. I'm sharing my slides with you. So I have basically 50 questions. So just because we do not have any students at present, so I would be only discussing with you the answers. You can just so this session will also be uploaded in YouTube. You can if you want to solve the questions on your own, you can just pause the video and solve the question and then get back with the answers which I will be discussing. So okay, let us start with today's quiz session. So this is actually, so I have collected the so I haven't started with the questions yet. I was just waiting. So okay, so we can start with you only then. Right. So I have 50 questions. 1 minute per question probably, or if you need some more time. Some questions are very easy. So these are the type of questions which I've already discussed before, but these are the type of questions you can expect in your exams and also these are the important questions from all the summarizing all the 12 lectures which were taught to you, and probably you have an upcoming exam. So when is the date of the examination? Is it I don't know about the date. Okay, that's not an issue. Okay, possibly if I'm not wrong it's on the 29th probably. Okay, in any ways, so I guess we can start. I guess my slides are visible. Okay, if that is so, I guess I can start with it. So is it visible? Yes, good. Okay, so the first question. Two weak acids A and B have a pK value of 4 and 6 respectively. So which of the statement is true? So which statement do you feel is correct? Acid A dissociates to a greater extent in water than acid B. For solutions of equal concentration, acid B will have lower pH. B is the conjugate base of A. Acid A is more likely to be a polyprotic acid than acid B. So which of the following statement do you think is correct? Okay, you say it is D. But see, the question says the pK value of A and B is given as 4 and 6. So from here, but B and C is incorrect because there is no information given about whether A and B has any relationship or not. So B is the conjugate base of A or not, we are not sure of it. For solutions of equal concentration, acid B will have lower pH, that is also incorrect. So if you see the pK value of the two acids which is given 4 and 6, so from this you can tell that your acid A will be will have or is acid A is a stronger acid compared to your acid B, and there is a tendency of strong acids to dissociate to a greater extent than the weak acids. So this has been taught. So from this, and also you do not know whether acid A or acid B is uh, in what form. So whether it is a polyprotic acid or not, no information is given, only the pKa value is given. So from the pKa value you can tell that the value is that the answer is A, because stronger acids dissociate faster than the weaker acids. Yes, so A is the correct option. Question number 2, the double beam spectrometer differs from the single beam spectrometer since the in the former. So what happens in the double beam spectrometer? So what of the following statements do you feel happens for our double beam spectrometer? Okay, you are saying it is A. Yes, that is correct. That for a double beam spectrometer, you see that when you go and see the diagram of a double beam spectrometer, you see two things. One is that you can measure both the sample and the reference simultaneously, that is correct. And also you are going to see that why you are going to measure the sample, or how, in what manner are you being able to measure them simultaneously. For that you have a chopper that splits the light into two parts, which passes through the reference and the sample cuvettes simultaneously. Because of this chopper, the light gets splitted and it enters the sample and the cuvette, and that is the reason why you can measure it simultaneously. So for question number 2, both A and C will be the correct answer. Okay, going to the next question. Question number 3. UV spectrometer uses two light sources from deuterium lamp and tungsten lamp. If the tungsten lamp stops working, in which way the measurements will be affected if the scan range is set from 200 to 800 nanometer? So how, in what manner is it going to affect your measurement and all? So your tungsten lamp is said to have stopped working. So what is going to happen now? You say it's D, that lower wavelength light will not pass through both the sample and the reference cell. No, that is not the correct answer. The correct answer here is that your light will pass through both the cells but up to a specific wavelength, because you see that one of your lamp has stopped working, and in this case the deuterium lamp works for the UV and the tungsten lamp works for the visible range. So if your, so one is between 200 to 400 and one is between 400 to 800. Now if you see that one particular wavelength has stopped working, then in that particular range of wavelength you cannot measure it. So but you can measure it for the other lamp as long as it is working. So you can, light will pass through both the cells but only up to that wavelength for which the deuterium lamp is working. So for this 3B is correct. Okay. Question number 4. Which of the following statement is true? In SDS page, all proteins are negatively charged. In native page, proteins can be negatively charged, positively charged, or neutral. In agarose gel, nucleic acids are positively charged. No denaturing agent is added in agarose gel electrophoresis. So this is an MSQ question. So which of the options do you feel is or are correct? You say it's A. Okay, in SDS page all proteins are negatively charged. That is true. Any other? Okay, no denaturing agent is added in agarose gel electrophoresis. That is also correct, because you do not add anything. How about in agarose gel nucleic acids are positively charged? No, it is incorrect. What about B? What happens in a native page? There is no SDS. The proteins will be in their natural charged state. So if a protein is negatively charged, it will be in a negative charge. If a protein is in neutral form, it will be in that neutral form. Or if it is positively charged, it will be a positively charged. So the role of the native page running is to run the proteins in their natural charged state. So option B is also right, because you are not adding any kind of denaturants and all which will add an uniform negative charge or a uniform positive charge. So in native page, the proteins, so from the name native, it states that the proteins will be in their natural charged form or in their natural charged state, whether it is positive, negative, or neutral. So A, B, D, all three are correct. C is incorrect. Okay, question number 5. If the concentration of H plus ion in a medium is 1.3 into 10 to the power minus 4 molar, what will be the concentration of OH minus in the solution? So what is the formula? Concentration of H plus into concentration of OH minus equals to 10 to the power minus 14 molar. So here you have been given the concentration of your H plus. So it's a very easy. You have to divide, means 10 to the power minus 14 divided by 1.3 into 10 to the power minus 4. So what is the value which you are getting? How much you are getting? So if you calculate it, you will get an answer of 7.7 into 10 to the power minus 11 molar. Yes, right. 5A is the correct answer. Okay, question number 6. The concentration of the protein should be kept low, should be kept very low during fluorescence experiment in order to. So why do you have to keep the concentration of protein very low? Have proper exposure of the amino acids towards the solvent, prevent aggregation of the protein, avoid change in pH of the medium, or avoid inert filter effect. So what happens in a fluorescence experiment? You have a cuvette, you put a protein solution, but the protein solution has to be of low concentration. Why? What happens if there is high concentration? If there is high concentration, then the light cannot enter it properly. Yes, and it will get stuck in the first phase and it will not reach in the center from which we are supposed to measure it. So in order to avoid the inner filter effect, we need to keep the concentration of the proteins low. So 6D is the correct answer. Okay, question number 7. Question number 7 says a graduate student is going to measure the concentration of BSA protein in phosphate buffer of pH 7.4, for which he has taken two different solutions in two cuvettes C1 and C2. The solution he should take during baseline corrections are. So what should that person take as a baseline correction solution? Such that because that is going to be the blank solution, and based on that he has to measure the concentration of his BSA protein. So what will be the solution he is going to take to measure the blank, or for checking the baseline, or for setting the baseline correction? What is going to be the answer? So it is said for cuvette 1 it is BSA, cuvette 2 phosphate buffer. Cuvette 1 and cuvette 2 both will be BSA. C1 phosphate buffer, C2 BSA, and C1 C2 both will be phosphate buffer of pH 7.4. So what do you feel is the right answer? C. Okay, why do you say that C1 is phosphate buffer and C2 is BSA? You are measuring the concentration of BSA in phosphate buffer. So two different cuvettes have been chosen over here, C1 and C2. So nothing is actually so for measuring, the cuvette 1 or cuvette 2 does not matter. The solution matters over here. So you will be measuring the concentration of your protein, and your protein is in phosphate buffer. So your molecule being in a particular buffer means you have to, so you see that you start walking from a distance 5 kilometers away from your home. Okay, and then you have been asked what is the distance of your school and your home. So but you have started walking and you calculate it's 10 kilometers because you have started walking 5 kilometers away from home, but that 5 kilometer is short. So like this manner, if your protein is in a particular solution, so that value of the solution will also play a role over here. So that we cannot do that, we have to correct it. That is called the baseline correction. So when your protein is in a particular solution, that particular solution or that particular buffer has to be chosen for your baseline correction. So in this case, both the cuvette 1 and 2, you are checking the BSA protein which is in your phosphate buffer. So the protein is in the phosphate buffer. So any cuvette you take, the baseline correction has to be done with the phosphate buffer itself of pH 7.4. So option D is the right answer. Okay. Okay, great. Question number 8. The pore size of a polyacrylamide gel can be changed by. How can you change the pore size of a polyacrylamide gel? Very good. By changing the acrylamide concentration. Okay, any other? Very good. By changing the acrylamide concentration and changing the ratio of acrylamide and bisacrylamide. Very good. That both are correct options. Okay, to reduce the pore size of agarose gel, one needs to. What do you need to do to reduce the pore size of the agarose gel? Yes, we need to increase the agarose percentage. So that will actually reduce the pore size of the agarose gel. Okay, the next question. This is another numerical problem. To prepare 500 ml of 100 millimolar acetate buffer at pH 5, dash volume of zero point 0.1 molar sodium acetate should be mixed with dash volume of zero point 0.1 molar acetic acid. So what is given? So the volume has been given, the concentration has been given. So what is the formula? You are going to use over here Henderson-Hasselbalch's equation. So what is going to be the answer? So after using the Henderson-Hasselbalch's equation, you have to, using the Henderson-Hasselbalch's equation, you have to solve this. So what does it say? Henderson-Hasselbalch's equation. pH equals to pK plus log of salt or the conjugate base by acid. So the pH has been given. Okay, so for acetic acid, you can consider the pK to be 4.74 or 4.7, anything. You can take that as the pK of acetic acid and do it. And then the concentration of sodium acetate is given. So over here you have to actually consider, like, the volume has been given. So the total volume is 500. So for one case it is X. So if you take for sodium acetate, it is X volume. You have to add. Then for acetic acid it is 500 minus X. And then you can find the value of X after, because pH is given is 5, and for the pK it is 4.74 or 4.7, whatever you take. So you subtract that and take the inverse log of that and then find the value of X. So if you do not have a calculator at present, when you calculate it, you find that the volume of sodium acetate to be added is 307 ml, and for acetic acid it is 193 ml. So question number 10D is right. For here you have to use the Henderson-Hasselbalch's equation. Okay, for question number 11, it says the UV absorbance around 278 nanometer in RNase A protein is solely due to tyrosine residues present in the protein. During an experiment, an absorbance comes of X protein comes to 0.4 at 278 nanometer when measured using a cell of path length 10 millimeters. The concentration of the protein present in the cuvette is around. Solvate epsilon value is given over here. So you know absorbance equals to epsilon Cl. So epsilon value is given, you have to find C, and the L value is given. Yes, it's 10 millimeter is given. So now you have to just calculate. Okay, the absorbance is has also been given. So 0.4 is given. So now tell me what is the concentration of the protein present in the cuvette. So all the values are given, only one entity you have to find out. What is the answer? So it is 0.4 divided by 9800 molar inverse, centimeter inverse, and with that it is 10 millimeter, which is equals to your 1 centimeter. So ultimately it is 0.4 divided by 9800. What is coming? So that is 4 into 10 to the power minus 1, and here it is 10 to the power of 4, around 10 to the power 4. So how much it is coming? It is coming out to be 40 micromolar. So these are the questions which these are the numericals from where there would be questions. So it is A equals to epsilon Cl. All the values have been given except for C. So C equals to A by epsilon L. A is given zero point 0.4 and epsilon 9800, and your L is 1 centimeter, which is also equals to 10 millimeter. Okay, great. Right. Question number 12. A new 5 rupee coin weighs 6 grams. Two new weighing machines A and B were tested with this coin by measuring its weight 5 times, and the following were recorded. So weighing machine A 5.97, 5.99, 5.98, 5.96 and 6, and weighing machine B 5.98, 6.01, 6.02, 5.98 and 5.99. So which of the following is true? A is more accurate, B is more precise. A is more precise, B is more accurate. A is more accurate and precise than B. A is less accurate and more precise than B. Which of the following is correct? So precision comes from your standard deviation, and your accuracy comes from the mean value. So after calculating the mean, if you are getting the value which is very close to your original value, that particular balance would be more accurate, whereas which is having a what to say, a very less standard deviation or a very low error bar, that particular weighing balance is going to be more precise. So now tell me what is it. So if you check the values carefully, what is weighing balance, what is the mean of weighing balance B? It is close to your 6 point something. So you say it is A, but see, when you calculate the mean of weighing machine A, it is coming something around 5.97 grams. But when you calculate the mean for B, it is coming around 6 grams. So in any ways, weighing balance B is accurate, is more accurate. Now whether B is more accurate, so it can be either D or B, because A has to be then less precise. Okay, but when you see for weighing balance A, it is only at a distance, the values are very close, about at a distance of 0.01 grams. Okay, whereas for the other you are seeing it is 0.03, 0.03 or 0.04 or sometimes 0.1. So weighing balance A is more precise because the values are very close to each other even if they are not accurate, but for weighing balance B they are accurate even if they are not precise. So for question number 12, B is the right answer. A is more precise while B is more accurate. Okay, question number 13. For accurate measurements of fluorescence emission, the cuvette should be. What should be, or how should a cuvette be? What should be made up of? So what should be the cuvette be like? Question number 13. So what should be the composition of your cuvette? Should it be made of glass, plastic or quartz, and then comes about the sides should be frozen or transparent? What should it be? You say it should be made of glass while two sides frost and the other two sides are transparent. Yes, that is the correct answer. Yes, because first of all it should be made of glass, second of all the two sides should be frost and the two sides should be transparent. The two sides which are transparent should be kept in line with your ray, or in the line with your light. So 13B is the right answer. Okay. Question number 14. The pK2, that is the pK of the side chain of histidine, is 6 when it is present in isolated state. Considering a specific protein with histidine at its active site, the pK2 is expected to be. How should the pK2 value change for histidine being in the active site? So see, if there are more number of positive charges, then you expect the pK value to decrease. That is why histidine is going to have a pK value which is less than 6 if your active site has more positive charges, whereas if it has more negative charges, then the value is supposed to increase. So for the time being, as it says that the pK value is supposed to be less than 6 if it is having more positive charges. Okay, so 614B is the right answer. Question number 15. During titration of glycine with NaOH, before and after the first inflection point, the change in pH is very slow due to. So why is the change in pH very slow when you are performing the glycine titration with NaOH? You say it's B due to slow deprotonation of glycine. No, because before and after the inflection point, this range is known as the buffering zone. So due to the formation of that buffering region or the buffering zone, that is the reason, because see, what is a buffer? When you are adding very small amount of acid, base or water, it does not show any change in the pH. So the change in the pH becomes very slow when it falls in the buffering range. So for question number 15, A is the right option due to the formation of that buffer region or the buffering zone. Question number 16. The number of possible tripeptide sequences are. So you are preparing a tripeptide. So how many amino acids are there? 20. So there are 3 places. Each amino acid having that capability to have all the 3 places. So can be alanine, 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 glycine, glycine, glycine. So in this manner, how many can you prepare? So it's 20 into 20 into 20. Right? So what is it? It's 8,000. Yes. The next question, in the peptide bond, CN bond has. So what does the CN bond have? Only double bond character, only single bond character, both single and double bond character, delocalized electron system. See, both single and double bond character, that is also correct, and because of this it is also creating a delocalized electron system. So both C and D are the correct options. Okay, the next question. Disulfide bond is formed between, right, two cysteine residues. So these have side chains as SH. So because of this, the disulfide bonds will get formed. Correct. Next set. In northern hybridization, probe hybridization forms. What does it form? I discussed this very recently. Should be correct. What happens in northern hybridization? What is your probe? And what is the material that you are detecting? Yes, RNA hybrid. Right. Question number 20. To detect protein in western blotting, what do you use as a probe? You use an antibody for detecting of protein. So first primary antibody, then secondary antibody attached with a enzyme which is going to fluoresce your substrate. Okay, the next question. A mixture of three proteins of sizes 50, 30 and 12 kDa separated by an SEC. In which order will they be eluted out? So what will be their order of elution? 50 followed by 30 followed by 12, or all of them will come out together? 12 followed by 30 followed by 50, or 30 followed by 12 and finally 50? Yes. So firstly the higher molecular weight proteins come out, then the middle order, and then the lower molecular weights. Correct. So 21A is the right option. Question number 22. When neutralizing buffer is added after lysis to the cell lysate, chromosomal DNA gets tangled and precipitates out. Plasmid DNA anneals and remains in the solution. Protein and SDS forms insoluble precipitate. Or all of the above. So when you are adding a neutralizing buffer after lysing it to the cell lysate, then what happens? Your plasmid, because you are actually, what you are doing, you are actually extracting your plasmid. So the plasmid DNA is going to anneal and remain in the solution. What will happen next is that before adding the neutralizing buffer, you have added another buffer which is known as the buffer P2, which will also, or this neutralizing buffer can also have those components and all. So that is also responsible for tangling your chromosomal DNA and precipitating it out. And finally your proteins and SDS forms the insoluble precipitates and moves out of the solution. So all of the three options are correct. So 22D. So first thing is that the chromosomal DNA gets tangled and precipitates out. Your plasmid DNA anneals and remains in the solution, and your proteins and SDS forms insoluble precipitates. Okay. Now DNA bound to silica membrane can be eluted. So how are you going to elute the DNA out of the silica membrane? So what are you going to add? What will help you in the elution of? Yes, it is water. The next question, the function of EDTA during cell lysis is to. So what is the function of EDTA in cell lysis? All of the above? No. Um, It acts as a metal chelating agent, that is right. Also, it inhibits cellular enzymes that degrades the DNA. So both A and B are the correct options. Okay, next. What is the function of NaOH in lysis buffer? Yes, it breaks down the cell wall. Correct. Next, what it says, at 280 nanometer, protein solution has an absorbance of 9 and a molar extinction coefficient of this. What is the concentration of the protein? So this is also you can do it. It is A equals to epsilon Cl, where your absorbance is given as 9 and your L is 1 centimeter and your epsilon value is 11460. So when you solve it or calculate it, you can get the answer. So you don't have to think much about it. The answer for the time being is 0.79 millimolar. So the formula is same, A equals to epsilon Cl. Okay, for salting out of proteins, which of the following salts is commonly used? So which is the salt you use for salting out of proteins? Very good. It's ammonium sulfate. Very good. Next, in Lineweaver-Burke's plot, the y-intercept gives you. So what is the y-intercept of your? No, that is the x-intercept. What is the y-intercept? Yes. 1 by Vmax is the y-intercept. Okay, question number 29. To measure enzyme kinetics, which of the following is varied? So what do you vary in enzyme kinetics? And what is the formula? V equals to Vmax, then there is a formula. Yes. So you do it, you calculate it, you are actually varying the substrate concentration. Correct. Okay, next. During non-competitive inhibition, the inhibitor binds to the site which is called the. So what does the inhibitor bind? Very good. Allosteric site. Which of the following determines substrate specificity of an enzyme? What determines the substrate specificity of an enzyme? Okay, the complementary geometry of the substrate and the enzyme, and any other thing? No, the degree of hydrophobicity or hydrophilicity of the substrate actually does not matter. So complementary electrostatics of the substrate and the enzyme will matter. So A and B both are correct. So the geometry also matters, the electrostatics also will matter. Okay. Protein denaturation by heat and urea mainly is caused due to? So what does heat and urea mainly do? They rupture the hydrogen bonds and destabilization of hydrophobic interaction. Any other thing? What is heat going to do? It is also going to displace the water molecule, the surrounding water molecules. It will actually increase the entropy of the water molecules and the displacement of the water molecules will occur. So both B and C are correct because you are providing heat. Urea is going to rupture the hydrogen bonds and destabilize their hydrophobic interactions. Correct. Okay, question number 33. Glacial acetic acid is added to two different proteins, protein X of Pi9 and protein Y Pi4 in equal amounts. Initially both proteins are at pH 7. Which of the following observation is expected to be observed? So what you are doing over here, you have to unfold a particular protein. So your protein will get unfolded. Yes, very good. Your protein Y will unfold at a slower rate than your protein X. Very good. Question number 34. This is a table which is given the different molecular weights and the different PIs. And which would be the following best result in separating of the proteins in the pure form? So how are you going to separate them out? The PI is more or less close to each other. The molecular weights actually vary. How are you going to separate them? Very good. It's size exclusion chromatography or the gel filtration chromatography. So first your C will come, then B will come out, and then lastly A. Right. Next. 35. 35. When the amino acid alanine is added to a solution with a pH of 7.3, alanine becomes. So at pH 7.3, in what charge will alanine have? Alanine has a pi very close to 7. Okay, so it will be in the zwitterionic form. It is going to be in the zwitterionic form. Okay, next. Question number 36. Multiple cloning site in a vector has. So what does multiple cloning sites in vectors have? Very good. It has unique restriction sites or the enzymes which are responsible for cutting off your DNA in particular specific, having specific sequences. Very good. What if your origin of replication is missing in a vector? What will happen if it is missing in your vector? The origin of replication is not present. Just very simple, the vector will not replicate. The next one. Tyrosine and tryptophan are less hydrophobic than phenylalanine because why is tyrosine and tryptophan less hydrophobic? A phenyl alanine side chain has phenol group in it. You need to check the structure. The answer is that phenyl side chain has no polar groups attached to it. Rather, your tyrosine and tryptophan has. So that is the reason of your tyrosine and tryptophan being less hydrophobic. But your phenyl side chain has no polar groups. Because of that, its hydrophobicity is high. You can check the structures. Okay, never mind. Ligand A and B bind a protein P with dissociation constant of 1 nanomolar and 100 nanomolar. Which of the following is true? So they have given the binding, the dissociation constant values, the KD values of 1 nanometer and 100 nanometer. Very good. A binds P more tightly because lower KD means tighter binding. Phosphate buffer is widely used because why do we use phosphate buffer? B, because it closely resembles the intracellular environment. That is right. Any other thing or any other option? Yes, its pK is in the biological relevant range. Because of these two reasons, phosphate buffer is widely used and preferred over trees. Okay, a protein will be positively charged when? When is a protein going to be positively charged? pH less than pi, greater than pi, or equal to pi, or does not depend on pi? If you are using a buffer which is of higher pH than your pi, then what will happen? So the pH of the buffer is more, it will try to pull your protein towards a higher pH range, and a higher pH range means what happens? A higher pH range means it is going to be negatively charged. So when the pH is less than your pi, only then is your the, a protein going to be positively charged. So remember this, pH less than pi means it's positively charged, pH greater than pi means negatively charged. So 41A is correct. Next, when NaOH is added to a solution of lysine dropwise, the number of inflection points or sharp changes in the pH obtained is or are. So how many sharp changes do you observe in the graph? Very good. It's 2 inflection points. Next question. During pH metric titration of glycine with NaOH, certain amounts of HCl is added at the beginning. Why do you add HCl in the beginning? What does HCl do? Fantastic. Complete protonation of glycine. Even if some of the glycines are in zwitterionic form or in any form, you add amount of HCl such that the entire of the glycines come to the becomes positively charged, and that will actually help in reducing the errors and calculating it properly. So complete protonation of glycine. For the complete protonation of glycine, you add HCl in the beginning. Okay. Question number 44. The pK of arginine's alpha carbonyl and alpha amino group and side chain is 1.8, 9 and 12.5. The isoelectric point of arginine is. This you can do mentally. So, what is going to be the answer? So, Pi equals to pKa watt plus pK watt by 2. You have to just tell that. So, Pi equals to pK2 plus pK3 divided by 2. So 9 plus 12.5 by 2, it is coming something around 10.75. So 44B. But for if it is an negatively charged amino acid, then it's pK1 plus pK2 by 2. Okay, the role of APS in SDS or native pages. So what is the role of APS in a SDS or native page? Yes. So APS is responsible for providing the free radicals, which is responsible for the cross-linking of the cross-linking reaction between your acrylamide and the bisacrylamide. Right. What is the role of BME in SDS? Breaking of disulfide bonds. Very good. These are direct questions. Okay, the next question. An alpha helix is stabilized by hydrogen bonding, which are formed between what and what? So the hydrogen bonding in an alpha helix is between uh, that one was okay. So D is for this question 47D. Yes, right. So CO and NH of the ith and the I plus fourth residue respectively. Yes. So 47D is correct. Now next one 48. A protein has the following amino acids in its sequence: methionine, cysteine, glutamic acid, glutamine, arginine, serine, proline, tyrosine, lysine, uh, and your glycine. So, which of the following alpha helix or helices are expected to be formed within the above sequence? So, which sequence is expected to form an alpha helix? Yes, because prolines and glycines are basically your helix breakers. They are mostly involved in turns. So when there is a proline, it will break your helix. So only the first 5 sequence will be involved in your alpha helix formation. So E is the correct option, where you will have methionine, cysteine, glutamic acid, arginine, and serine. Okay. Okay, we have the last 2 questions. Buffers used for biological experiments should have the following characteristics. Right, they should be chemically stable and water soluble, and they should not interact with your biological molecules. So these two are the correct options. So the last question for the day: before loading the protein onto the chromatography column, the following treatment is made to the column. It is equilibrated with the protein which is to be isolated, washed with ethanol to remove impurities, equilibrated with buffer which is used as the mobile phase, or washed with the matrix solvent. Before loading the protein into the column, chromatographic column, what should you do? So just before the loading of the protein, you do not wash it with ethanol. If you do it in the before starting an experiment and after completing the experiment, and then you wash it with water. So first you wash it with ethanol, say, then you wash it with water, and after that what do you do? Just before loading your protein. So how do you load your protein? You have to use a buffer for that. So for that you need to equilibrate your column with that particular buffer, such that when your protein goes, it does not get contaminated with anything other solvents, but remains in that buffer. So you equilibrate with your column with that particular buffer, you load your protein, and then you again pass that buffer, the complete loading is done, and then you go for the elution stage. Then after your experiment is done, you wash it with ethanol, and then you get your protein in hand, and after that you wash it with ethanol, and then the experiment is done. So yes, question number 50C is the right answer, that you are equilibrating with buffer which is used as a mobile phase. Okay, so that's all from my part. So these questions you can check back even in YouTube. I will be uploading them in YouTube as well, so you can check back when you get some time. And that's all from my part. So those who have exams, best of luck for your exams. And I am done with my live session. We'll meet you probably in the next, not in the next semester, the next year. So that's all from my part. Thank you all. Hope you have a good time ahead. So thank you all, and best of luck for your exams. Be calm headed and do a great job.